Hello all, this is Maita. Today I'm going to present on machine translation, a research paper that I have been doing as part of my final project. Machine translation is a subfield of computer linguistics and helps a user to translate a text from a source to a target language. The main idea of machine translation can be dated to 17th century, but the main progress in this field was in recent years. In 2012, Google announced that Google Translate can translate each day 1 million each day the text that can fill 1 million textbooks. And the graph to the right shows the machine translation market size worldwide to be in the by 2024. It is predicted that by 2024, the market to hit 1,500 million US dollars, which shows how vast this field is growing. And the various machine translation systems that are in the market are rule-based machine translations, where it mostly uses the linguistic information to translate from source to text. A transfer-based machine translation, which uses some intermediate representations like language independent, which are partially language independent to translate. Interlingual, which is which generates source is translated to intermediate, completely language independent form and translated to a target language. Dictionary based statistical machine translation, which uses some statistical methods like bilingual corpus, etc., to translate. And example based hybrid machine translations are just a combination of both rule based and statistical machine translations. And neural machine translations, which has gained its importance in recent years and which uses deep learning techniques to translate into a target language. This approach is gaining huge importance and vast areas going on in this approach. This neural machine translation has huge neural machine translation systems perform very well compared to the all traditional based machine translations, which makes them stand out of the group. So, as neural machine translation is being used currently in most of the systems, we are trying to focus our approach on mostly on the neural machine translation. So, basically, what is neural machine translation? It's an artificial neural networks are used to translate a sentence from source to target. The deep neural machine translation is just an extension of neural machine translation, and both these approaches use large neural networks, but the only difference is that multiple neural networks are used in deep learning machine translation compared to a single layer in neural machine translation systems. These neural machine translations require very small amount of memory, as they have inbuilt memory, which makes them stand out from this traditional machine translation systems, and it is easy to train the models as they require less memory. Some of the applications of these neural machine translation systems are it's being used by most of the gains in the market like Google, Microsoft, Yandex, etc. And neural machine translation as of 2017 have been used by in most of the sectors like government, software, military, healthcare, etc., and also for the online and app translation for customers, etc. These translations in real time can not only be text to text, but it can be text to speech, speech to text, speech to speech, and image to text, etc. So, the NMT architecture mostly uses recurrent neural networks for translating a sentence from source to target. The main difference from the traditional neural networks is that in traditional neural networks, it assumes that all the input and output elements are independent. But coming to the recurrent neural networks, we have the information both from the previous state and current state, which help us to predict the next what happens in the next state, which makes them stand unique from other traditional machine translation approaches with their capacity to store the information in the memory. There are various recurrent neural architectures like vanilla RNN, gated recurrent unit, and long short-term memory units. Vanilla RNN is the first recurrent neural network that was developed. This architecture is very simple. It has an input layer, hidden layer, and an output layer. So the hidden layers act as a memory for the which stores information from the previous and the current state, which can be fed to the next hidden or the output layer. The limitations of this approach is that its instability while learning. The gradient coefficients might either explode or vanish, which makes them difficult to optimize. The another recurrent neural networks that has been gained its importance is the gated recurrent neural networks. This has been developed recently and introduced in 2014. Its architecture is similar to the long short-term memory, but performs well on smaller datasets. They don't have any inbuilt memory in them, but they have two gates like reset and update. The reset determines how to combine the new input, and with the previous memory, and the update how much previous memory to be kept around. So, based on the weights, this reset and update will maintain the information about the source vectors. These are very bit new and haven't been completely explored, but the main advantage of this architecture is that they have few parameters compared to the long short-term memory, since they have just the reset and update, which makes them faster to train the model. Long short-term memory is an extension of recurrent neural networks which eliminates the problem of memory storage. LSTMs are developed to perform well on longer sentences since they store the information of the current and previous states of longer sentences up to a length of 50 words. They contain three gates through which the information can be read, write, or deleted based on the weights that being received from to the current state. The predictions are being made. These are widely used to overcome the problems encountered in sequence-to-sequence translation, as the source and target may not have the same length. Attention-based long short-term memory, which have gained their importance in the recent year. The main difference from the LSTM is that attention is given to a global or to a set of words in a sentence. The latest technology gains like Google, Baidu mostly use this architecture. These eliminate the fixed length memory that is being used in LSTM, as they have variable length memory. And attention is paid to a specific set of words, thus reducing the computational expense. Attention models can be of two types, like the global and local attention models. The global attention model consists of we can see that hidden state. HS is a hidden source state. AT is a global alignment weights. So for every hidden target word, weights are assigned based on which a context vector, all the words that are relevant in the context are added to the context vector based on which a target word is translated in the target language. So the main drawback of this approach is that every target word in the global context word, for every target word, all the context words that are global, like the whole sentence is considered, which makes them computationally expensive. So which gave rise to local attention models. In local attention models, for every target word, the words in the source are given a local weight. So based on these local weights, the context window is selected with the most words that had given high maximum weight, and based on these window in words in the context vector, their corresponding target word is translated in the target language. So experiment was performed to compare how the attention models have performed when compared to the base models, like the base model like LSTM. It has from the results we can observe that the ensemble technique using the local attention in all the models has performed was the best model. Again, the analysis was performed on mainly on following factors like learning rate. So out of all the approaches, the base model with local attention and has the less learning rate, fast learning rate. And it's also analyzed on their ability to handle longer sentences. We can see that local attention models have performed well compared to non-attention models, which is in red. We can see that the local attention models have performed well, and the best one was the one in the blue. That's an ensemble of all the models. And some of the limitations in this approach are that a single sentence is considered at a time. If you have a text of data, only a single sentence is considered, which a sentence to sentence relationship isn't maintained, is computationally expensive, and its quality depends upon the size of the corpus. So we can say that neural machine translation is an active research area, and almost 47 research papers were published from December to 2017 to 18 February. So this is a very active research area, and these are the best machine translation systems that are currently available in the market that are used for machine translation. The main advantage of this approach is that they consider the whole sentence. In languages that have long dependency, neural machine translations perform well compared to the traditional approaches, and they can capture the complex relationship between languages. And the latest machine translations are being used by the big gains in market like the Google, Apple, etc. Thank you.